All right, so buckle up, everybody, because today we're diving into something that might just change how you think about learning, especially when it comes to science.
Yeah, it's a pretty cool topic.
We're going to be looking at video analysis and just how much it's starting to shake up physics education.
Yeah, it's a lot more exciting than it might sound at first.
Yeah.
Get ready to see those textbook equations come to life.
Okay, so the jumping off point for our deep dive today is this super interesting project. It's out of Singapore. It's called Becoming Scientists Through Video Analysis.
Oh, I've heard of this.
Yeah, and it's not just like a small classroom experiment or something. It's this whole initiative,
Huge.
yeah, involving multiple schools,
Wow.
and even the Ministry of Education got involved.
Really? That's impressive, the Ministry of Education.
Yeah, and it even went on to win a UNESCO award
Wow.
for its approach. So it really makes you wonder,
Yeah.
what is it about using videos to learn physics that's so special?
Right.
It's not like we haven't been using videos in classrooms for ages.
Forever.
Well, what makes this different?
Well, I think, you got to think about it this way. Physics is all about motion, forces, how things interact in the world. But on paper, it's a lot of formulas.
Right.
Video analysis kind of flips the script. You know? Imagine, let's say, watching a video of a skateboarder doing a trick. You're not just seeing those cool moves, but with the right tools, you're actually seeing the physics in action.
Yeah, it's like giving those abstract concepts an actual physical form. You can observe it.
Exactly. And that's what real scientists do too. I mean, all the time in research labs. High-speed cameras, motion tracking software, that's how we understand how birds fly or how galaxies move. Students aren't just learning about science, they're actually doing science.
That's so cool. Yeah, it's such a different way to think about it, Instead of memorizing formulas, you're actually applying them to the real world. So how does this Becoming Scientists project actually make that happen? What did they do?
So one of their key tools that they use is software called Tracker, which we'll talk about more in detail later. But Tracker basically lets you analyze videos frame by frame.
Wow.
You can track the movement of objects, actually measure their speed and acceleration. You can even create models to test your predictions about what's going to happen.
So it's like having X-ray vision for physics. You don't just see the event, you see the forces at work.
Yeah, exactly. And it's not just for a select few. The project created a library of these tracker experiments, and they actually made them available online as open educational resources.
Oh, wow.
Yeah, so anyone can use them.
That's really cool.
It's about making these tools accessible to everybody, right?
Right.
Teachers anywhere can bring video analysis into their classroom now.
That's amazing. And, they actually did.
Yeah.
The website was talking about multiple journal articles, conference presentations, even a publication from the Ministry of Education.
Nice.
They were really contributing to, the field of science education research.
Yeah, and it shows, their success is kind of culminating in this UNESCO award, which proves that this hands-on learning actually is effective. It's not just a gimmick, it gets results.
Okay, so we've got engaging tools, real-world applications, proven results. Okay, I'm starting to see the potential here, but what are the bigger implications? Does this only apply to, physics classrooms, or could this be used for other subjects too?
Well, that's where things get really interesting. Think about biology, chemistry, even social sciences. Imagine analyzing animal behavior or tracking the spread of a disease over time.
Yeah.
You know,
You could analyze historical footage or study human movement in sports and dance.
all right, or even
The whole world becomes a laboratory.
exactly, the possibilities are, practically endless. And now with, smartphones, everyone's got a high-quality video recorder. This is becoming more and more doable.
So we're not just talking about a few schools in Singapore, are we? We're talking about a potential revolution in how we teach and learn science globally.
Exactly. And the Becoming Scientists project really highlights that potential. But there's another layer to all this that I think is worth exploring.
Oh, I'm all ears. Tell me more. What else is there?
Well, we talked about the impact on schools, but what about the potential for citizen science? What about everyday people contributing to research using these tools?
That's amazing, you know. Imagine anyone with a smartphone could record a video of a natural phenomenon, then they analyze it using Tracker and share their findings with, scientists.
Exactly. It's like democratizing scientific inquiry. We could use the observations of people all over the planet.
It's a powerful thought, and it really aligns with the idea behind becoming
Oh,
scientists.
absolutely.
They weren't just, focused on training future physicists. They were trying to foster that scientific mindset in everybody.
That's a great point. It's not just about this specific knowledge. It's about learning those skills to ask questions,
Mm.
and gather evidence. Draw conclusions from your observations. These are skills that are valuable, like in any field.
Yeah, and I think they're becoming more and more important, especially today when we are just bombarded with information from all sides. Being able to critically evaluate that information, figure out fact from fiction,
Hmm,
that's really important.
absolutely crucial.
And so you're saying that video analysis can actually play a part in that?
Oh, definitely. By doing video analysis, even just a little bit, people start to understand the importance of, like, evidence-based reasoning. They start to look beyond just the surface and dig into the hows and whys of the world around them.
It's like training your mind to see patterns and connections that you might otherwise just miss.
Exactly. And that kind of thinking is useful whether you're trying to understand science or evaluate a news article or even just make a decision in your own life.
Right. Okay. So I see how this all connects. It's not just about physics. It's not even just about science. It's about a way of thinking, a way of approaching the world with that curiosity, that desire to understand how things work.
And that's really what the Becoming Scientist project was all about.
Yeah.
They showed us that science isn't just something you do in a lab. It's a way of interacting with the world around you. It's this constant learning and discovery.
Speaking of discovering, I'm actually really curious about this tracker software. I mean, we've mentioned it a few times, but what exactly is it? What
Sure.
makes it so powerful?
Tracker is open source.
Mm.
It's a video analysis and modeling tool. Basically, it's software that allows you to track how objects move in a video, frame by frame.
Oh, wow.
So you can upload a video, let's say that skateboarder video, and mark the position of the skateboard in each frame.
Okay.
And from that, it can calculate things like its speed, acceleration. It can even predict the trajectory of the skateboard.
So we're talking about like kinematics, projectile motion, all those concepts we talked about earlier, but actually being able to see them play out.
Yeah, you can experiment with different models and see how changing variables affects the outcome. It's really amazing.
Okay, that sounds incredibly powerful. It's no wonder this project had such a positive impact on student learning. But how difficult is Tracker to use? Is it something that requires, a lot of technical expertise?
Not at all. And that's one of the really great things about Tracker. It's designed to be user-friendly.
Yeah.
It's got a relatively intuitive interface,
Mm-hmm.
and there's tons of tutorials and resources available online.
Oh, that's great. So it really does seem like this technology is becoming, more and more accessible.
Mm.
But we've been kind of focusing on the student experience. What about the teachers?
Right.
How did this project impact their approach to actually teaching science?
That's another really key aspect of the project. They didn't just create resources for students. They developed professional development programs for teachers, too.
Oh,
They held workshops, shared their curriculum materials, so they were empowering other educators to
Yeah.
adopt these methods.
that's so important. I mean, it's one thing to develop a new approach, but it's a whole other thing to make it sustainable,
Right.
By training teachers, they ensured that this approach could spread beyond just their own classrooms.
Exactly. And those training programs made a big impact. Thanks to their efforts, a lot more educators are incorporating this into their teaching, not just in Singapore, but internationally, too.
That's really cool. So we've got this amazing project that's, sparking innovation in the classroom. It's inspiring new scientists, potentially even changing, how we think about learning itself. But before we wrap up, I want to go back to that citizen science idea. Are there any potential downsides to this idea of democratizing science through smartphones?
That's a really great question. It's definitely important to realize that citizen science isn't perfect. One of the biggest concerns is making sure the data collected is good and reliable.
Because, anyone can contribute. It doesn't matter what their level of expertise is.
Right, exactly. That can lead to inconsistencies or even biased data. So it's important to have systems to validate the data, to make sure it meets, quality standards before it's used for research.
So it's not just about handing everybody a smartphone and saying, go be a scientist. Right. There needs to be a structure.
Absolutely. And that's where, scientists and educators are really important.
Mm-hmm.
We need to develop clear protocols, provide training, and make sure there are strong systems for validating the data.
It sounds like there's a lot of potential, but it's not a simple solution. You really need to think it through. But even with those challenges, this idea of citizen science, it is still pretty exciting, right? It's like tapping into this huge, pool of human curiosity and observation skills.
Oh, it really is. And I think, the Becoming Scientist project has shown us that with the right tools and support, anyone can make real contributions to scientific knowledge.
Yeah. And who knows, maybe someday one of those big contributions will come from a video recorded on a smartphone
Wouldn't that be amazing?
and then analyzed using Tracker.
Yeah, that would be a testament to just how powerful technology can be and how deep that human desire is to understand the world.
It really makes you think. But I feel like we've only just started to explore this topic.
Oh, yeah, there's so much more to uncover.
There's so much more to talk about.
Absolutely.
There's so much more to talk about. Where do we even begin?
Well, we've talked about Tracker a bit, but I think we should really dive in and, give it the spotlight for a minute.
Okay, yeah, let's do that. What is it about Tracker that's so special? What makes it so powerful?
So Tracker is this, well, it's open source, right?
Hmm.
And it's a video analysis and modeling tool. So it's basically software that lets you track the motion of objects in a video frame by frame.
Frame by frame, wow.
So let's say you upload that skateboarder video we were talking about, right?
Okay.
You can actually mark the position of the skateboard in each frame of the video.
Okay.
And from that, Tracker can calculate all these things, like the skateboard's speed, its acceleration. It can even predict the trajectory of the skateboard.
So, like, we're talking about kinematics, we're talking about projectile motion, all those physics concepts we talked about. But now you can actually see them play out, right?
So,
With that?
yeah. And you can even experiment with different models,
Yeah.
see how changing different variables affects the outcome. It's really cool.
That sounds incredible. No wonder this project had such a positive impact on student learning. But I'm curious, how difficult is Tracker to use? Is it something that requires a lot of technical expertise, or can anyone use it?
That's one of the things that's really great about Tracker. It's designed to be pretty user-friendly.
Hmm.
It has a relatively intuitive interface, and there are tons of tutorials and resources available online, so you can kind of figure it out as you go.
Oh, that's really good. So it really seems like this technology is becoming more and more accessible, for just about anyone who's curious enough to use it.
Yeah, definitely.
But we've been, focusing a lot on the student experience. What about the teachers? How did this project impact how they actually approach teaching science?
Well, that's another really key aspect of the Becoming Scientists project. They didn't just create resources for students, they also developed these professional development programs for teachers.
Ah, I see.
So they held workshops, they shared all their curriculum materials. Really, they were empowering other educators to, adopt this method of video analysis in their classrooms.
That's so important. It's one thing to come up with an innovative approach, but it's a whole other thing to make it sustainable and make sure that it spreads. So by training the teachers, they really made sure that this could go beyond just their own classrooms, right?
Absolutely. And the impact of those programs, it's been significant. More and more educators are incorporating video analysis into their teaching, not just in Singapore, but all over the world, actually.
That's amazing. So we've got this really incredible project. It's sparking innovation in the classroom. It's inspiring new scientists and potentially even, changing how we think about learning itself. But before we wrap things up, I want to go back to that idea of citizen science for a moment. Do you think there are any potential downsides to this idea of democratizing scientific research through, smartphones and stuff?
That's a good question. It's important to acknowledge that citizen science isn't without its challenges.
Right.
One of the biggest concerns is making sure that the data that's collected is actually good data,
Right.
that it's reliable.
Right, because anyone can contribute regardless of, their level of expertise or their background.
Exactly. And that can lead to, inconsistencies, inaccuracies, even bias in the data.
Mhm.
So it's crucial to have some kind of systems in place to actually validate the data and to make sure that it meets certain quality standards before it's used for, research purposes.
That makes sense. So it's not just a matter of handing everybody a smartphone and saying, go do science, right? You need structure. You need some guidance.
Yeah, absolutely. And that's where the role of scientists and educators becomes even more important. They need to develop those clear protocols for collecting data. They need to provide the training and the support for the citizen scientists. And they have to establish, strong systems for validating and analyzing that data.
Yeah, it sounds like there's a lot of potential, but it's definitely not just a simple solution. It requires a lot of thought and a lot of collaboration to make sure that it's done right.
I agree.
But even with those challenges, the idea of citizen science is still pretty exciting. It's like tapping into this massive, untapped resource of human curiosity.
Yeah, the potential is huge. And I think the Becoming Scientist project, it's shown us that with the right tools and the right support, anyone can make really meaningful contributions to scientific knowledge, no matter who they are or where they come from.
And who knows, maybe one day one of those contributions will come from a simple video that someone recorded on their phone and then analyzed using, free software like Tracker.
That would be amazing. It would really show how powerful technology can be in, empowering anyone to become a scientist.
Yeah, it's really inspiring to think about. But I feel like we've only just scratched the surface of this whole topic. I mean, there's so much more to explore here.
Oh, there's definitely a lot more. We could talk about this for hours.
I know. But unfortunately, we're out of time for today's deep dive. But I hope you enjoyed exploring the world of video analysis and science education with us. And I really want to encourage you to keep that curiosity alive. The next time you see something interesting, something that makes you wonder why, grab your phone, hit record, and see what you can learn. You never know what you might discover. And hey, maybe you'll even make a groundbreaking scientific contribution along the way. That's it for us today, folks. Until next time, keep exploring, keep asking questions, and keep diving deep.
Wow, we've covered a lot of ground in this deep dive.
Yeah, we have.
From those classrooms in Singapore,
Yeah.
all the way to global citizen science projects.
Yeah. It's amazing to think about how it all connects.
It really is. It's definitely changed how I think about, how we learn and how technology can actually make us more curious about the world around us.
And that's one of the things I love most about this project, becoming scientists. It's not just about teaching physics, it's about getting people excited to learn.
Right.
That desire to explore and experiment. Yeah, and they did it in such a clever way by using video analysis. They tapped into something that's already so familiar to so many students, watching videos.
Right. We all love videos.
Exactly. But they added that extra layer of scientific inquiry. It turned passive viewers into active investigators.
It's like they made learning into a game without actually turning it into a game.
Mm-hmm.
It's fun, it's engaging, and it's actually relevant to students' lives.
And I think that's a key point, right? That relevance.
Absolutely.
I mean, so often science can feel really disconnected from the real world.
Totally.
But video analysis brings it back down to earth. It shows how those concepts, those abstract concepts, they actually apply to the things that we see and do every day.
Exactly. Whether it's that skateboarder doing a trick or a cupcake falling or, a rocket launching.
Right.
Physics isn't just equations in a textbook anymore. It's the forces that literally shape the world around us.
It's happening all the time. We just need to know how to look for it.
We need the tools to actually see it. Yeah.
Exactly. And those tools are becoming more accessible all the time.
Right. Think about smartphones. Everybody has one.
I know.
They're like these portable science labs,
They really are.
High-def cameras, powerful processors.
It's crazy when you think about it, all that power in our pocket.
I know, right? And projects like this are showing us how to use it, to learn, to discover new things.
It's like we have this blueprint now for a more engaging, more effective way to teach science.
And to learn it, too.
Exactly. And it's not just limited to the classroom, right?
No, not at all. Anyone can use this approach.
Students, teachers, parents, or just someone who's curious about the world.
It's really for everyone, yeah.
All you need is your phone, a little bit of curiosity, and a willingness to ask why.
That's it.
And on that note, that's all the time we have for today's deep dive, folks.
Already?
I know, time flies when you're having fun, right?
Yeah.
But thanks for joining us as we explored this world of video analysis and science education. We hope you learned something new, and most importantly, we hope we've inspired you to keep exploring, keep asking those questions, and keep diving deep into the world around you. Until next time.
Bye, everyone.